Hi, I have a question for you. Let's design Twitter. Especially, I'm more interested about how you can design Twitter timeline.
Okay, so first of all, thank you for giving me this opportunity to attend this session. So your question is basically to design a Twitter,
Yes, Twitter service.
and the emphasis right now that you are giving is on the timeline.
Yeah.
Okay, so as we know that Twitter is a service where users can share limited short side messages,
Yes.
right? Uh, at this point, the requirement that you gave me is quite open-ended, so we need to nail down some of these requirements
Mm-hmm.
to set up the scope and expectations for designing the system.
Yes.
Uh, so yeah, so as you have just mentioned that we have to pay the special emphasis on the timeline, but that's something that came slight afterwards. But first of all, we need to nail down some basic requirements.
Mm-hmm.
Twitter is about tweet. Okay, so let me start by enumerating all the functional requirements that are required to design this system
Okay.
for your expectation. Okay, uh, I should be able to write these requirements in this document.
Yes.
Okay, this is a text block. Okay, so let me check if I can make it bold.
So, are you able to write to it?
Yes, I am able to write to it. So yeah, okay. So what a user should be able to do with this system.
Mm-hmm.
Uh, as we have said, the purpose of Twitter is to post some limited size messages.
Mm-hmm.
So that's what I am writing it right now. Users should be able to post. Okay, so I will come to the details later that what will be the size of messages and other things. Okay, okay. So if you look at the real world Twitter service, a user should is able to follow the other users,
Yes.
right? Uh, in the system that you want to design, is it a requirement?
Yeah, I think, of course, what you want to see in the user home timeline, the messages
Okay,
or tweets from other users.
okay. Since you are talking about the timeline, is the user able to mark any of the tweets as his favorites?
Yeah, that's fine.
Okay, now since you are talking about the timeline, I believe there are two kind of timelines in the current Twitter service.
Mm-hmm.
One is the timeline where I can find all the tweets of the people who I follow,
Mm-hmm.
and one is my home timeline. So do you want me to design both of these or any one of these?
Yeah. So, yeah, I mean, both of these would be fine. I think let's try the first. We will try to do the one which is a timeline where you can see the tweets from other users which you follow. But yeah, if we can get both of them done, that would be great.
Okay. So your current emphasis is basically on the timeline.
Mhm.
So should I worry about any other feature of the Twitter like search?
No, right now it's fine. We don't need to.
That it's fine.
Yeah.
Okay. 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 Since the emphasis is on this timeline, so what do you think will be the acceptable latency for me to view my timeline?
What do you?
Is it uh, I believe it can be like, I believe it can be like something like 500 milliseconds.
Yeah, I mean, we would like the latency to be as less as possible.
Yes. So anything between 100 and 500 is good. So this is
Mhm.
just a magic number.
Yes.
So I'm just putting it 500 millisecond. Right. Uh, Once again, another question regarding the cap. Do you want system to be more available?
Yes.
Okay. So if we have to select one thing between availability and consistency,
Hmm.
what should I prefer?
I mean, what do you think? What would the system should behave like?
It depends on system to system. Personally, I think for this kind of system, availability is more important than consistency.
Okay. What would the consistency would look like in this system?
Uh, Look, at this point, we can just think about some issues of consistency. For example,
Mhm.
take example of a user who is very popular.
Mhm.
Okay, and this user has like millions of followers.
Mhm.
Uh, so this any of his tweet, it's supposed to be broadcasted to everyone.
Yes.
Okay, and obviously it will not reach to anyone, every person at this, that we will discuss later how we're going to design it. But right now we can think that it may not reach to everyone at the same time.
Yeah. It may not. Yeah.
It may not, and there is a possibility that it used to a user who replied to that message, and that reply is available to my timeline even before the original message was posted.
Hmm.
This is something I can think. So that's why I was saying that in this case, availability is more desired than consistency. But it doesn't mean that we are compromising on consistency.
Yeah, but let's say if I ask you to design this strongly consistent, would the strongly consistent Twitter service would look like in that case?
Okay, so in case of strong consistency, I can give several examples since you are focusing more on the timeline. Uh, for example, if a message, if suppose if I follow you, okay,
Mm-hmm.
and I also follow like Barack Obama,
Mm-hmm.
right? Now Barack Obama posted a message,
Mm-hmm.
okay, that has not yet reached to my timeline,
Yes.
but it somehow reached to your timeline, and you replied to that message.
Okay.
And since I follow you, I can see your replies in my timeline.
Yes.
Okay, so here we have a consistency problem because that message, since I also follow Barack Obama, that message didn't arrive at my location and it first went to your location.
Okay.
Okay, and your reply came to me first,
Mm-hmm.
even before when Barack Obama original message came to me. Okay,
Mm-hmm.
so this is the consistency issue. So if we want to guarantee the consistency,
Mm-hmm.
so then we need to design a system in such a manner that till all the Barack Obama's followers have received the message, okay, no one can post a reply to that message.
Okay. Okay. So
This
what
is
do you think right now? What would be better approach?
uh, since we are talking about a compromise between consistency and availability, I think this kind of system is more desired to be more available.
Mm-hmm. Yeah, I think because it does not make, I mean, even sense. Like if Barack Obama, like I think there are like millions of users who follow Barack Obama. So if you
Uh,
right now try to make sure that all those millions of users first get the message,
yes,
and then you like you see I mean, there might be ways, I think, but let's see. Okay, right now I think
yes. Once we design the system, and then we will. see
Yeah.
how this which you can build. Okay. Uh, Before we dive into the thick of things, so I just want to more further know something more.
Mhm.
So you said we are not currently concerned about searching for the tweets.
No,
We are not currently concerned about like replying to the tweets,
no.
any kind of hot topics, uh, and notifications. So at this time,
Mhm. That's fine.
okay. So armed with this information, I believe we can move forward to our next step. And our
Any
next
other
step,
requirements that are important still for the timeline?
okay, yeah. So that's what I have just written down for the timeline, what requirements are.
Mhm. I mean, I'm talking about the non-functional requirements. Are there any other non-functional requirements that you think?
Okay, the first thing that I wanted to discuss was the latency, right?
Mhm.
Other thing was whether availability is preferred over consistency or not.
Mhm.
Okay, and any other non-functional requirements.
What do you think about scalability and durability?
The system, okay, so I have intentionally not written down as yet because this is something what I'm going to discuss in my next step.
Okay.
So it's okay. So I will continue to fill this table
Mhm.
and gather some more information from you
Okay.
regarding the.
Mhm.
Okay. Now, I'm drawing another box here, but I will continue to edit this box also
That's fine.
because I for the scalability requirement, I have some different questions.
Mhm.
Okay, to nail down more non-functional requirement, I have some question from you.
Mhm.
How many total registered user will be there?
What do you think?
Uh, I think considering the future requirements, I mean, if let's consider the state of a service after 5 years from now, that I think the total number of registered users, I'm not saying the active user, the registered users can be like something like 2 billion.
Mhm.
Okay. Okay. Now the another important question, how many active users per day? So here I am, let's select like 500 million. Okay.
So those
Uh,
are the ones who are posting or who are actually just receiving tweets?
that's a good question. These are the people who log into the system on average every day. Okay, and they are not necessarily posting.
Okay.
They can just be viewing also, and they may be posting also.
Okay.
Okay. Okay. Now that how many tweets per day? So let's write the same value. Okay, on average. So obviously, in a particular day when something like election or something is going on, then there are more tweets than that. And there are some days where less number of tweets, but this is just an average value that I have been
Okay.
writing here. Okay. So currently, I think this is 140 characters.
That's fine.
Okay. Okay. I have some more. I have to get some more statistics here, but I think you are at this time we are not concerned more about the search and any other thing. So we are only concerned about the timeline. So I'm not writing anything else here.
Okay.
Uh, Now storage estimates. So Twitter is all about tweets. So, and we need to store these tweets somewhere to, for example, if I send a new tweet, it needs to be stored somewhere so that anything can be done with this. That it can be populated in other users' timeline, or it can be searched, or it can be analyzed for any other purposes. So right now, so as I said that we have 500 million tweets.
Mm-hmm. So with those,
Sorry, I just lost my this browser window. Just wait for a minute. Sorry, I'm using two. Here, where it is. Sorry, here it is.
with 500 million multiplied by 140 is around something like 500,000 million, which is
Mm-hmm. Here, the calculator, 500 million multiplied by. Okay. Kilobytes, megabyte. Which is something like 65 GB per day.
okay.
So I have to convert it to per second. So
I mean, that's fine.
60.
Yeah, that's fine. I mean, we know that this much. We are trying to estimate the storage. So in a day, 65 gigabytes. In a
Yes.
in a year, might be 65 multiplied by 65 gigabytes, etc. Do we need to delete old tweets? What do you think? Do we need to delete old tweets or not?
So in order to conserve the space, yes, it depends on our policy whether we want to delete the old tweets or not. Yes. So for example, we can create a policy that the tweets can be maintained for 2 years only, not more than 2 years.
Okay. That's fine. Let's go to a little bit further. I like to see the design, how the design would look like.
Okay.
We already like 20 minutes.
Mm-hmm. Okay. Now let's move move to the design. So let me open this another screen. Okay. So before moving to the design, so what I would like to do is to start with the REST API.
Okay.
Okay. So we already have a functional requirements there, and I want to start with the REST API to make sure that we are designing the right system. So user should be able to post. Why I have written this post requirement is that because without a tweet, it's not possible to create the timeline. So that's why. So the first function will be okay. User can post a tweet.
What's the auth token contains?
Okay. So it is service specific authentication parameters.
Okay.
for example, if we are since we are designing the system and creating the infrastructure ourselves, the security token is our specific. That's what I'm going to discuss. But there are times when we are hosting this service in some kind of cloud service provider. For example, if you want to store it in the AWS, then we need access key, secret key, session token. So this is a security token that is currently assigned to the user who has successfully logged on to the system.
Okay.
Okay, so this security system can this authentication token can be used by the service itself to ensure that it is getting the message from the user who has been authenticated.
Okay.
Okay,
That's fine.
and
Let's go further.
And it can be used for other purposes also, like API rate limiting and many other things. Okay, so we are not concerned about deleting or liking the tweet, or we are not concerned about. We are concerned about the follow user. You'll see. Okay, that's follow user. Okay, now the important thing for this interview session: read home timeline. So whenever I first log into the system, I want my timeline to be displayed here. So this timeline, so we can have a policy, like for example, we can only have like 40 messages in the timeline in a single page.
Okay.
Okay.
Mm-hmm.
So I think these are very self-descriptory.
So this is what I'm trying to send you this int page ID. What is this page ID? It's an ID of a page or a number? The page number.
Yeah, that's a good question. So there is a possibility that there are 200 fresh tweets that are supposed to be displayed on my timeline. Okay. Here I am mentioning the page size, the last parameter. So for example, I don't want more than 40.
Okay.
Okay. So then it chopped those set of tweets, dividing them by 40. Okay. And I start with the page ID of 0, and for the subsequent pages, I will say 1, 2, 3, 4.
Okay.
Okay. And the API will also tell me how many pages are remaining.
Okay. But let's suppose you call this API, let's say read user timeline, and you pass this page ID or home timeline, page ID 0, and with page size of 40, it doesn't use some set of tweets, like 40 tweets. But now what happens is that you call now page ID 1. Okay.
Okay.
And during that time, while you are about to call, some new tweets come also.
Yes.
Which got added in at the head of the whatever the timeline you have. So what happened now? How you will not be able to see those tweets in that case?
Yes. So now it depends. So this read home timeline can be extended. First, it can be extended to have some kind of sort order, ascending or descending. Okay. Suppose if I have a descending sort order, right? Which means I want the latest tweet first. Yes, in that case, for the first time I will get the latest set of the tweet, but the second time, what we need to do is to now we need to decide what to do again. When I send this call again, either we get the new messages that are posted and send it back and recompute the remaining pages size. Okay, that is one possibility, or just continue the old paging.
Okay.
That was going on there, but in this methodology, we need some kind of track at the server side.
Okay, let's see. Let's go to design first, and then we can go deep.
Okay. Right. Okay. I need to add a new page here. Our next topic is the component design. So suppose if we plan for the subsequent 5 years, then that's what we know, that we require a good amount of storage. So okay, sorry, let me move back one step backward. So right now I am concerned only about posting a tweet. A new tweet is getting posted. What is going to happen at the server end?
Okay.
So at server end, let me obviously a new call of post tweet is made. It goes through the load balancer, then it will get to the set of servers, and subsequently it will end up in a database. Okay, let me start backward. Let me start from the database itself. How are we going to design the database? Okay, so we know that something like what the calculations we have made is 64 GB per day. If we talk about suppose if we want to store the messages of up to 2 years, okay, then we can make the calculation. It will be like 65. It will be something like terabytes, like something like 200 terabytes.
I'm not worried about the
okay, that's the storage. Okay, that's the storage required. So why it is important? It means that in order to store these tweets somewhere, we need a database which should be partitioned.
Yes.
Okay. Here I am suggesting a NoSQL database like Dynamo. Okay, we can also use the SQL database. There is nothing wrong in it in this case. But since these NoSQL databases, since these databases like Dynamo, they're easy to partition. So I'm suggesting these kind of databases. Okay, we need to partition the database for efficient storage and retrieval. Okay, now what is our partition strategy? Okay, so this is a tweet. Okay, when the tweet reaches the server, okay, but that I have not drawn yet. I'm going to draw it. So, but because I want to discuss the database itself, what the server is going to, it will create a tweet object. The tweet object contains the tweet and its metadata. Okay, the important element that is supposed to be computed first is the tweet ID. Okay, the server will compute the tweet ID. How is compute? I'm going to discuss it. Now the server needs to store this tweet along with the user's identity in some kind of database shard, since we are partitioning it. Okay, which shard is supposed to be used? There are different techniques we can use. The first of all, we can create a hash of the user ID itself and store it in particular shard. Okay. But I mean, there is a drawback here, is that if this user is what you can say a hot user, okay, and many people are following them, and many people are loading the timeline simultaneously to get the tweet of that user, then there will be a lot of load on that particular server. Okay, because all the user tweets are being stored at the same server. Another thing we can use is to use what we can say the tweet ID and hash it. Okay, and then use some kind of consistent hashing mechanism to select the shard in which that tweet can be stored. Okay, so it means for a particular single user, for example, Barack Obama, if Barack Obama posted a tweet, there is a possibility that it can be stored in one server, and for the next tweet, it can be stored in some other server. Okay, so the only pitfall here is that now when Barack Obama's tweets are supposed to be retrieved, all the shards are going to take a hit. Okay, there will be at least single call to all the servers in the shard.
But now it won't be just the Barack Obama. For every user's tweet, you have to hit all the shards.
Yes, you have to hit all the shards. Okay, so yeah, these are the.
Which approach will you prefer?
So I prefer the second approach.
Shard by tweet ID?
Yes.
Okay.
Okay. So yes. So for a single person who has been currently being followed, a one call is going to be made, although it is going to be made for every server there, but it will be for a single user, there will be one call. So that's why I'm preferring it.
No, but now for all the different users which are tweeting, you will still be
Yes.
calling, and then now you will still, like, even in the previous case also, for all the users, I mean, there will be a single call only for a tweet, no?
No, so okay, let's talk about the previous case. In the previous case, all the Barack Obama's tweet are on the same server,
Yes.
on the one server.
Yes.
Okay. Now, suppose 500 followers have load their timeline simultaneously.
Mm-hmm.
Okay. So all those 500 calls will come here.
Okay.
Okay. All the 500.
the same
Mhm. So all the 500 calls will come here, and data will be retrieved
Yes.
and sent to all of them.
Yeah. But now in the second approach, even in second approach, if there are 500 users who try to load their home timeline,
Yes, the home timeline. So
those
as
500 users
yes, so
will go to say still all the partitions now. No?
yes, now all the partitions will be accessed, but as you can see, we can later optimize by introducing the cache.
So why not you can optimize it the first case by introducing a cache?
Not necessary. So what example? For example, let me explain you. There will still, so how can I explain? So there will still be a load on the server. In case, sorry, let me step back. Let me step back. Okay, in the first case, what we have is all the servers are accessed at once. Sorry, single server is accessed by the 500 users simultaneously.
Mm-hmm.
Okay, but the other servers are not getting accessed. Okay, one user access and get it. Okay, yep, you are correct. So yep, there are in this case, I don't think there is in both the techniques there. The advantage of the second approach is that suppose if somehow that server is not available,
Okay.
okay, or the cluster is not available, basically the shard is basically it itself a set of cluster where the backups are also available, they are not available, then in this case the system may continue to work.
No, but usually this is not the case. We don't do that. Like any server and the backup of the server, we don't put them in the same cluster. Like we never put them in the same fault domain or availability domain usually.
Oh, that is correct, but in just in case if it's not available for whatever reason.
No, I mean, then in that case, let's say what will happen in the other case. If there's a partition or a shard which has the latest tweets is not available, then the users will not see the latest tweet from that user.
Yes, data streams, but they can still see the other tweets from that user.
Okay.
Because they are distributed in the other servers also.
But let's suppose the users are usually users always see the latest tweets. So if someone is okay.
Oh, sorry. So then this is a consistency issue.
Mm-hmm.
Yeah, in that case, the latest tweet will not be available unless we have some more fault tolerance built into the system.
Mm-hmm. So I don't understand like how even if you think that the second approach is better in which you are sharding by the tweet ID. Because whatever the reasons you are giving, I feel like they apply to the same, to the other approach as well.
Okay, let me think about that. Okay, in the second approach, what we are doing to we have sorry, let me move back. Let me move back. In the first approach, what we were doing is that we have a database. All the data of celebrity like Barack Obama at a single server. Okay.
Yeah. It's not a single server, it's a single partition. And of course,
it's a single partition. Sorry, it's a single partition. That's a better word to say.
In that case, the partition, the way if you go a little bit like deeper into data storage, you know how the partitions.
Yes, these are partitions. Okay. So 500 people load the timeline. and the request came to that server. Okay. Data, since it was there, the data will be retrieved. It can be sent to the cache or back to the users. Okay. So I'm still thinking how it can be better.
Okay, but now let's think about it. Now let's see the home timeline. How the home timeline will be generated. Like when a user try to query his home timeline,
Okay.
like how it will look like this procedure.
Sorry. Okay, sorry. So let me go back to the previous issue. So another issue that can happen in the so I know you have you have moved forward. So another issue that can come if we are storing a lot of tweets on a single server.
Okay.
Okay, that's the amount of data can grow a lot on it.
But we discussed already that we might be deleting all the tweets older than 2 years.
No, for example, if there is a celebrity tweet,
Okay.
or a celebrity is tweeting a lot of messages. Okay, so
How many?
these messages are not.
Let's say a celebrity is tweeting how many messages per day?
Suppose a celebrity can put 10 messages per day.
10 messages per day.
Yes, and if there are multiple celebrities.
Okay, but if there are multiple.
Okay, and yes, but in case, for example, if there is some kind of event, there's some kind of sports event or anything, then people can people can store people can send more messages, so there will be more load on that server.
Okay, but then wouldn't it then boil down to the partitioning, the way we will be partitioning? Like if the partition size is very big, where like there are multiple celebrities on the same partition, maybe then we would like to rebalance the partition in that case.
Okay, so but there can still be a lot of load on that server. So the number of records that are accessed from the server will always be high.
How do we then avoid this type of when we try to access the records from a partition?
Sorry, can you repeat your question?
How we actually, if there's a load on the partition, how we actually avoid the load on the partition? Like how we can minimize the load on a partition? If there's a read load, for example.
So if you want to avoid a read load, then you can either either repartition it.
Okay.
Okay, number one, or you can add, if you are using consistent hatching, you can add more nodes in the shard and map new items here, which is second more complex. Typically, it is
consistent hashing to add more nodes. Is it repartitioning or not? Is it not repartitioning?
Yes, it is also repartitioning.
So what then? I didn't get it. What's the difference between the first approach and the second approach?
So sorry, let me talk about the first approach itself. So basically, they are very much the same. So in the first approach, so what you can say, so what you're saying in a single partition, there is too much load for whatever reason at any time, then we can further repartition that node using some other criteria.
What do you mean repartition?
For example,
I mean you break the partition into multiple partitions. Yes.
Yes.
Which is the same as the second thing.
Yes, it is same of the second thing.
So then, what's the difference between the 1 and the 2 that you were telling?
No, you can skip the 2. You can just ignore the 2. Maybe I was doing something else.
Okay.
Okay. Okay, sorry. Okay, so what was your next question? Sorry, I interrupted you.
Was that, let's say now how the home timeline of a user is generated.
Okay. I have not drawn anything yet, so I'm going to draw it before. Okay, so how the user timeline. Okay, so yes, I started with the tweet. So a tweet is posted, and we are using what you can say. We are storing the tweet in the particular shard, and how and which shard is get selected. It depends what we have said. It will be decided by the tweet ID.
Okay.
Okay. Now I have once that tweet has been posted. Okay. Now it is supposed to go. It should be available in the 2 different timelines. Okay. So the first time, okay, so then within now this our architecture is basically an architecture what you call microservice architecture. We have another service that can be queried to get the list of the followers
Okay.
of a person who posted this tweet.
Okay.
Okay, so this is also what you can say a key value store. Okay, where the key is the user ID. Okay, and its value is basically you can say something like a hash set of all the user who have attempted to follow the user
Okay.
before using the follow user API. Okay, I have not implemented the follow user API yet. Okay, but to answer your question, okay, so the service wrote it to the database. Okay, we have not introduced any cache yet. Okay, everything is in the database yet. Okay, then the service will find the followers of the current user. Okay, now we have discussed the two microservices, one that is storing in the database and the second which can be queried to get the people who are following the current user. So here I am also introducing another concept called in-memory, a service that generates in-memory timeline of the particular user.
Okay.
Okay, what this service does is that for any user who has logged in at least once in a month, okay, it will compute the in-memory timeline.
Okay.
It can be used like Redis cache or anything cache service. Okay, and that will remain in memory and it will continue to update it. Okay, so I'm giving a very high level description. Okay? So whenever a user logged in or the user requests his timeline or the home timeline, that information is available. So in this cache, what is stored is the current user ID, the user ID, and it is mapped to the tweet IDs.
Okay.
Okay. For example, my user ID is 10 and there are 40 tweets, so there can be like 10 entries for me, 40 entries for me. Either can be 40 entries for me or there can be one entry with the value which can be a hash set.
Okay.
Okay. Okay. Let's assume that I'm following the first approach. Okay. Since there are 400 tweets waiting for me, there are 400 entries. Okay. For all and the key is my user ID and the value is
how this will be generated. How are you generating this thing? That I'm trying to understand. When do you generate periodically? Like
yes.
That I'm trying to understand.
Okay. So this service is periodically generating it. Okay. Number one, this service is periodically generating it. One. Other than that, the first service that we have discussed that's stored in the database, that service is also supposed to update it.
Okay.
Okay, that service will add it in the database, get the followers list from the other service, and then it also send a message here, either to communicate with this service or directly access this cache to provide the update.
Okay.
Okay. Okay, here is a problem. So another thing I suppose is that suppose since I follow Barack Obama, okay, and this is a celebrity. So in case Barack Obama posted a message, nothing will happen to my timeline.
Okay.
Absolutely nothing. So this I am suggesting because that message is supposed to be distributed because there are millions of people timeline who is supposed to be updated.
Okay.
So whenever I issue this read home timeline, this internally this function will read the information from the cache. After reading it from the cache, it doesn't send me. Then it will check the list of the people who I follow, and there are celebrities, and then get their latest tweets, append them, and then send it to me.
Okay. Okay, I'm going to stop here now because we are now over time.
Yes.
Okay. So yeah, thank you.